Um, let's see. All right. Good evening, everyone. Can you guys hear me okay? Yes? Okay, perfect. Okay. Unfortunately, against my better judgment, I'm going to record this.
Recording in progress.
All right. Okay. So I will add some more problems in the problems that I've added to the review that's already posted. And those will be mostly word problems. So by tomorrow mid-morning, I should have something posted, or by posted, I mean emailed to you. Anyway, okay, so any questions? Everybody got the location of the exam? Perfect. Okay. So let's start. So again, review works the way I've done it before. That means I don't go ahead and review all the material, but I'll take questions. Final exam from 1D. Which one's that? Okay, so is that the name of the file? Are you looking at the name of the file in the all section site? Is that what you're doing? Rain?
Yes, it's on section 13 to 15, final exam, final exam review, final review for 24th.
Okay, so there's no file on our section that's called that. So let me ask you, is this the problem with the limit and the sum? With the Riemann sum? Is that what you're talking about?
Yeah.
That's the one? Okay, so this is the one that has an integral. It's equal to a limit and a sum. That's this one?
Yes.
Okay, perfect. Okay. That's a sigma. So, okay, equal 1 to n. And then I have some stuff here. The stuff here will have this form. Okay, that's the form it's going to have, no matter what it looks like. This is the form. So, because what did they do? They took a function, and I'm not saying the graph of the function is above the x-axis. It could be above, it could be below the x-axis. The graph could be a little bit above, a little bit below, but the function is continuous. We don't care where the graph is. But let's say it's here. It doesn't matter where it is. And you have A, B, and somebody's trying to find the signed area. And the way they did it, they broke this thing into strips. And to make life easier, they made the strips all have the same width. This thing. How many strips? Well, they used exactly n strips. So this delta x here, it will be equal to b minus a over the number of strips. Again, this tells you the number of strips. So whenever you see something like that, whenever you see stuff times something that looks like this, some number over n, this number over n, that's your delta x. And that tells you both what A is and what B is, pretty much. So you do have something like that in what's given to you. What's given to you is limit sum, and you have a bunch of stuff. And then you have, what is it? 3 over n. Yeah? So this bunch of stuff, that's this. We'll get to it later, right? So that means this quantity is your b minus a over n. B minus a over n is 3 over n. So you can simplify this So therefore, b minus a is equal to 3. Okay, so b minus a is equal to 3. And this integral, this limit of a sum that finds the actual signed area, could be positive or negative, is equal to the integral from a to b of f dx. Here they're giving you a bit of everything. They gave you the a, here it is, right? So you already know what the a is. And they're asking you for b, you have no idea what b is, right? B is this thing. So one of the questions is find b. So, well, since b over minus a is equal to 3 and a is 8, you can find b, right? B is what? What's b? 11. B is 11. Now, this is an exam. So you do 3 plus 8 and you end up with 3 minus 8 because, you know, somebody coughed next to you. Things happen. So what would you do? You'll be super slow on this. B is equal, let me see, I have to change the signs. Leave it alone. Leave it like that. You don't want to put 3 plus 8 is equal to 12 because you have a bad day and write on the box 12 because the way, unfortunately, we're going to grade this, and that's instructions from the coordinator, we're going to look at your answer. If your answer is incorrect, so you wrote 10, but I can see you have the right thing in the work, I'm going to have to take points off for that. Whatever the answer is worth, I'm going to not give you those points. So please don't add. Right, so this area that you're trying to find, the way you find it again is you take strips and you zoom in and you say, okay, instead of finding the area inside a strip, because I can't, geometry doesn't help me, because geometry doesn't like things that are curvy on top. It likes rectangles, you know, trapezoids, squares. Geometry can handle the area of those things, you know, right triangles or non-right triangles. Geometry can give you area. Geometry doesn't like the curve on top. So you say, okay, geometry, since you don't like the curve on top, I'm going to help you. So what you do is you take either a right-hand point or the left-hand point or a midpoint. So let's say you take the right-hand point and you make everything the same height. Same thing here. Make everything the same height. Make everything the same height. So you find this area, which geometry can help now. You say, oh, that's a rectangle. I can handle that, right? So the geometry says the area then is equal to the width, which is your delta x, times the height, and you chose the height. Right? The height is this number here. So this is the width. This is the width of the strip, which is your delta x, which by definition is the length of the whole interval divided by how many pieces you have, right? If the interval is 100 feet long and you divide it into 2 strips, each strip will be 100 divided by 2. Right? If the interval is from A to B is 100 feet long and you divide it, I don't know, into 20 little strips, each strip will be 100 divided by 20, 5 feet long, right? So what is delta x? Delta x is going to be B minus A, this length, B minus A, divided by how many strips you have, right? So this number here is B minus A divided by N. So this number here is the length of the width of each subinterval. So it's that thing. But that's what it's equal to, right? So this stuff that you see, you have a parenthesis times stuff. The stuff there is your B minus A over N. Okay? So since B minus A over N, that's your delta x. That's given to you to be 3 over N. You get rid of the n's, the B minus A is equal to 3. And since you know A is given to you, is 8, you can find B. So now you have the interval from 8 to 11, or whatever B is, right? And by definition, this is going to be, again, the limit f of xk times delta x. We're done with that. We're not interested in that anymore. And they're asking you to find f of x. What's the formula for f of x? So if you have an interval from a to b, and you cut it into however many subintervals. So this is the first, this is the second, and this is the last one, the nth one, little subinterval. And then you create little strips and you create rectangles, right? You have options for the height of the rectangle. You can take the left endpoint, you can take the right endpoint, you can take the midpoint, whatever you decide. Usually in these problems, at least for the exam, it will be either the left endpoint or the right endpoint. So since you know 8 is your leftmost endpoint, you can pretty much tell. Okay, I did, yeah. That was bad. You can pretty much tell, but the way this sum is given to you is given to you this way. 8 plus some stuff to the negative 5 plus natural log of 8 plus some stuff plus 2, and then your delta x. That's your delta x. This is your f of xk. Okay. So whether you choose the left endpoint each time as the height or the right endpoint each time, this f of xk is going to look a certain way, and you can tell which point they chose. So if I were to choose the left endpoint each time, this endpoint for the height, then my first interval will have area, well, let's see, the base, which is delta x, times the height, which is going to be f of a, and a is 8. So that would be my first y value, okay? The second y value, if I were to choose, again, the left point, my second y value, I can see it in the area. The area, again, is going to be base times height. The height is going to be the value of the function at the left endpoint. The left endpoint is 8 plus a little bit. How much is the little bit? Delta x. So f of 8 plus a little bit. So that's going to be my second y value, right? So if I were to use left endpoint approximation, this stuff here, when I open up the sum, the first term would look like f of 8 times delta x. Second term, f of 8 plus an interval times delta x. And the next one's going to be f of 8 plus 2 of these times delta x, and so on. But if I were to choose a right endpoint approximation, this is your first x value, which is 8. And the heights are, I don't know what the heights are, nobody cares. And let's say for the first subinterval, I want to use the right endpoint. Then this area here is going to be base times the value of the function, not here, but here at the right endpoint. The right endpoint is not 8. It's 8 plus a little bit. What's the little bit? Delta x. So 8 plus delta x. So that would be my first term in the sum, right? Now, the question doesn't ask, are you using left endpoint approximation, right endpoint approximation? Really doesn't care, right? Doesn't care that you know which approximation they used. So even if you don't know which approximation they used, you can tell what the function is. Because regardless whether you use this left endpoint approximation or the right endpoint approximation, where the first term will be this term, here it is, So the right endpoint approximation looks like this. The sum is f of 8 plus delta x. That's the first term times the width plus the next height times the width plus the next height, and so on. Regardless, since you know 8 is your leftmost endpoint, you try to find the 8 in that formula. So here it is. Here's the 8. Here's the 8. And here's the 8 in the formula they gave you. Here's the 8. Here's the 8. You already know this thing is your function, where somebody has taken the x and replaced it by different values. Either they replace the x's by the leftmost endpoints, this one and this one and this one and this one, all the way to the left ones, or they replaced all the x's by constants, and those constants were the right most endpoints, all the way to the last one. Right? Doesn't matter, but the x's are replaced by numbers now, plus a bit of delta x. So you find where the 8 is, where the leftmost endpoint is, your a. You find it in your formula. That along whatever, however many delta x's, that's your x. So this thing here, this whole thing is your x. This whole thing, 8 plus a bit of delta x's, this whole thing is your x. So your function should be this x to the negative 5 plus natural log of x plus 2. That's your function. Okay? So if somebody gave you, there was a similar problem that I gave you. So somebody gave you, where's my problem? This. Where is it? Oh, yeah. So there's a mistake there. Well, there says 23. It's 2. It's not 23. Plus whatever. When you see k over n, when you see the k, this thing here is the number of delta x's that they're adding to the leftmost endpoint. The next one is a plus delta x. The next one is a plus 2 delta x. These numbers here are represented by that. Okay, so so I gave you, what is it? To the 3/2 times 9 over n. Right? So you have, again, this will have the same form. The function times delta x. So that's your delta x, right? Same thing. And delta x is always b minus a over n. And again, they gave you the a, I think. Yeah, gave you the a. The a is 2, right? So this is 2. So you can find b. And the rest, this whole thing is your f, where the x's inside your f of x are replaced by a plus a little bit, a plus a little bit more, a plus a little bit more. So you'll see inside the f, instead of x, you will see a constant, and that constant has to be your a. Your a in this case is 2. So again, I wrote here 23, and it should be your a, which is 2. It should be just 2. Right? Just I'll fix that. Anyway, so this thing should be the f of x, with the x being replaced by a plus a bit of delta x's. So since delta x is that, how many delta x's you have here? You have k of them. So that means, and here's your a plus a bunch of delta x's. So this is your x. This whole thing is your x value, that somebody keeps on replacing it by different values. Right? So your f of x then is that x to the 3/2, because there's a 3/2 there. That's your function. Okay, so it's pretty straightforward looking at this to see what your function is. You don't have to do much. Okay, so so I'm not going to answer that question, Arian, that you email. Okay, so please don't send direct messages, because I don't want to talk to someone. I don't want to answer here a question that seems private. But, you know, just look at the reviews that I've posted. So okay, so you said which, okay, so let's do one at a time. Which 2D, is that in the same review? Okay, 2D. Did you say why it's not positive or why is it not negative? Let me see, what's your question? Oh, okay. Okay, then, well, it shouldn't be positive. So let's see why. Well, actually, oh, yeah, it should not be positive. Okay, so before I do 2D, let me show you something. So suppose I say find this as x goes to infinity. If x goes to infinity, then x is already here. It's going to infinity, it already has started the trip. It's way on the positives. So x is a positive number already. If x is a positive number, then, you know, there's really, the absolute values is an overkill. We can get rid of them. So you can say, okay, that's 1. Because you already know x's are positive, right? But if I say to you, then you know one thing is for sure, since x is way towards negative infinity, x is already negative. X is in here already and keeps on moving on the left, more and more on the left forever, right? So x is negative. If x is negative, then the absolute value of x is equal to what? How can I simplify it? Did somebody answer? Negative x. So since I know I'm going to negative infinity and x is negative, right? First of all, you can't take a limited derivative and integral with the absolute value sign. Right? You can't. You need to get rid of the absolute value. So you can't just say, oh, I know what the answer is. Just, you know, get this idea. Right? Don't do that. Get rid of the absolute value. So your first job is to figure out whether the answer to the absolute value of x is x or negative x. That's what you have to choose. And it doesn't matter what's in the denominator, right? What matters is x is positive or negative? That's what will tell you how to replace absolute value of x. Since x is negative, then this is the same thing as the limit as x goes to negative infinity of negative x over x. And now you can simplify and the answer will be negative 1, right? So now let's get to the problem. Suppose I ask you this, how to simplify this. How are you going to simplify that? Okay, they're all wrong. Fantastic. I love it. Okay, so these are all the possible wrong answers. Okay, I didn't ask you. Stop. So, right. The answer to such a question, first of all, should be one answer, not two, right? One answer. Second of all, you can do a little problem. Even roots, whether it's a second root, a fourth root, a 2000th root, any even root, the answer should be not negative. It can be 0, but it can be negative. So it can be plus or minus for even roots. So at the very least, I know the answer has to be not negative. It can be 0. So if I write x, I don't guarantee that. I don't guarantee that the answer is not negative because I have no idea what x is. Maybe the x is negative, right? So I have to guarantee the answer is not negative. So I'll do what Aditya says. I do this. So for even roots, when you simplify and you take something out of the root, you have to guarantee it's not negative. So if you're not sure, if it's the number 3, you know it's not negative. If it's an x, stick absolute values, unless you know for a fact that x is not negative, right? So the same thing with this. If I do, what was it in there? Yeah, so if I do, now if I do this, I don't have to worry about it. This I simplify, right? So remember, this is the same as x to the 4th. The root, the square root is the same thing as a half. So this is the same as x to the 4th times a half times, which is x squared, which I don't have to worry about. Absolute value is clearly not negative. So I don't have to worry in this case. But if I have something like this, like I do in this case, I can't write x to the 3rd because that number could be negative, right? And the fact that this is an even root requires the answer is not negative. So in order to guarantee that, I need to stick absolute values because numbers to a 3rd power can be negative, right? So the other thing, when you have, whatever root, let's say a square root, and you want to take the x to the highest power out, you can factor it first inside the root. So 1 plus 3x over x to the 7th. Simplify it, x to the 7th, 1 plus 3 over x to the 6th. And then take it out of the root, and it's going to come out as, well, that's unfortunate, x to the 7 over 2, which nobody knows what it is. You have to guarantee this is a positive number, right? So I'm going to put absolute values. And the rest stays inside the root. Okay, so these are the kind of stuff we need to do in this problem. So this problem says, find the limit as x goes to negative infinity. X is certainly negative because it's in its way to that side, the left side. So x is negative. X to the 3rd plus 1 over root x to the 6th plus 3. So how do you evaluate this? The best way to evaluate when you have access to different powers, even if you have roots, and the x goes either to infinity or negative infinity, the best thing to do is take the x to the highest of the highest power outside on top, and take the x to the highest power outside, factor it out on the bottom. So I'm going to take x to the 3rd out on top. Keep in mind the x is negative. So I'm going to take the x to the 3rd out, and I'm left with 1 plus 1 over x to the 3rd, right? So when you take an x to the 3rd out, you divide every term by this thing that you factored out. And I'm going to do the same thing in the denominator slowly. I'm going to first take it outside of the, stuff inside the root. So 1 plus 3 over x to the 6. And now I'm going to attempt to take this outside of the root. So I want to simplify square root of x to the 6. I would write x to the 6 over 2. Initially, it's incorrect. And then I realized, wait a minute, the x was negative. This could be a negative number. But wait a minute, this is an even root, does not allow negative numbers. This is a second root. That's an even number, second root. So it does not allow negative numbers. X to the 3rd could be negative, so I really have to stick absolute values around that. Okay, so when you take it out, it becomes, when you take it out here, it becomes limit as x goes to negative infinity, x to the 3rd on top, 1 plus whatever. On the bottom, you have absolute value of x to the 3rd and the stuff inside the root that are left. Okay. So, and now you need to take the limit. So you really want to get rid of the absolute value somehow. And you ask the question, okay, what is x doing? X is going to negative infinity. So is this absolute value of x to the third, what do I write? What is that equal to? Since I know x goes to negative infinity, I'm not saying what the limit is. I'm asking you, how do I get rid of the absolute value in this case? Let me see. What do I have? Yeah, so I have to write negative x to the third. That will definitely be equal to a negative, right? So I'm going to replace this by negative x to the third because I know x is negative, right? So then this limit is equal to the limit. Again, I haven't taken any limit yet. I simplify, so I can please simplify the x to the third, so I still have a negative sign there hanging out in the bottom, right? And then I take the limit. As x goes to plus or minus infinity, here doesn't matter. This quantity goes to what? The 1 over. This goes to 0. This quantity goes to 0. So those things go away. That goes away. And you end up with 1 times another 1. And on the bottom, you're left with negative 1 times square root of 1. So the answer is negative 1. Okay? This is a standard problem in an exam. What's ty? Okay, don't know what that is. Oh, okay. 3b. Okay, yeah, so 3b is also the standard problem. So fundamental theorem of calculus, part 2, the world says, and Thomas says part 1. Whatever. So the fundamental theorem of calculus, part 2, says this, and this can be any variable that's not x. It will be t, y, probably not, t, u, whatever. So it's t, fine. So because a integral kind of reverses a little bit what the derivative does, this will be equal to f. So this will kind of go away in a sense. So you're left with f evaluated at x. So that's the fundamental theorem. Now, how can this change? Well, still this is a derivative. This is still a differentiation formula. This says the derivative of this type of thing is that. That's a differentiation formula. So for example, if I say to you, the derivative of this thing is equal to that, and you're like, cool, now I'm going to remember that. So then I say, okay, I'm going to make it worse. So how about e to the stuff? And you say, no problem. I'm going to use the basic rule. I'm going to use e to the stuff. And because you changed my x and you made it weird, I'm going to use chain rule that says that weird thing derivative, right? That's exactly what you do. So if somebody takes this formula and changes it a little bit on you and puts something weird here, like I don't know, x squared or 3x squared, you're like, no problem whatsoever. What I'm going to do, I'm going to use the same formula that says, if this is x, plug in x inside the function. But now the x is not x, it's 3x squared. So what I have to do is plug it in inside the function. So the answer would be f of this weird stuff times, the chain rule says, the derivative of the weird stuff. And of course, you need to finish this. So f of 3x squared times 6x. So how can it change further? It can change further by somebody reversing the order of these. So if the x is here and the a is there, every time you flip the limits, the answer will be opposite. So you just have to stick a negative sign. So again, those will kind of cancel, but the answer will be negative f of x. So all these come together in this problem. So this problem says find the derivative with respect to x. So see, the x's are replaced by weird, right? Sine x. So not only that, if they're not in the top limit, they're in the bottom limit. So the answer is going to have a negative. It really doesn't matter what that number is. Nobody cares. So you look at it like, okay, cool. But you really don't care what that is. And you have a function. You don't care what the function looks like. And it has t's. It won't have x's. So this is your function, your f of t. So in this case, the square root of something plus something else, dt. So get the answer should be negative because the x's in the limit are on the bottom. The answer will have this function, and all the t's are going to be replaced by that. So it's going to be this function 2 to that weird limit plus 7. The t is going to be replaced, sine of x, and that t is to the second power. And because, again, the x is on the bottom, the sine x is on the bottom, I took care of that, I put a negative, but also it's not a plain x, it's something more. So I need to multiply that root by using the chain rule by the derivative of sine. So the answer will be all that, right? So the answer should be negative root of that stuff times derivative of sine, which is cosine of x. That is outside the root. Okay, and all this comes here. So again, the 8 doesn't matter at all. And you can try that on your own. We had one like that in class. So you can put different A's and say, okay, I really think it matters. I don't believe you. You really shouldn't. You should try things out. So let's do, I don't know, 1 to, let's do a simple one. 1 to x of whatever, something that I can integrate quickly. E to the t, I just want to make it easy, plus sine t dt and derivative. So you say, fine, first I'm forced to do this. So you're going to do that and then take a derivative. So you integrate that, so it's e to the t, integrate that, that gives you negative sine t, and then evaluate from 1 to x. And once you're done evaluating, then you're going to take a derivative, right? Now, this is the thing that somebody could have changed. So, right, it could have been 1, could have been 0, could be negative a half, could be something else. So you plug in the top limit. So notice the x's are going to replace all the t's. So e to the x minus sine x minus what you get when you plug in the 1. When you plug in the 1, it really, nobody cares what you get. Because this 1, that could have been a 2 or it could be some other number, now it's going to disappear on you because the derivative is coming to get rid of all the constants. So this did not matter. Whether it was a 1 or a 2, the derivative will just make it 0. Right? So all that matters is this. And when you, again, differentiate this, you're going to end up with, what am I doing here? No, that's cosine. Thank you. Cosine. Cosine x. Okay. The integral of sine is not negative sine. It's negative cosine. So now I'm going to differentiate this. This is going to be 0. So again, the constant did not matter at all, right? But the derivative is going to give me exactly what I started with. The derivative of cosine is negative and another negative is positive sine. So it gave me exactly what I had, but with x's. Okay, so the a did not matter. It doesn't. Ah, yeah. Okay, so was there another problem? 15 on one final review for, okay, so 15, what's 15? Ah, yeah. So, oh, extrema. So if you have a function that has 1 piece, 2 pieces, 3 pieces, 5 pieces, whatever. And that goes from A to B, and that goes from B to whatever, and that goes from C to whatever, right? And you want to find the absolute extrema. Well, for the absolute extrema to exist, you must be able to apply the extreme value theorem. That is, you must have a function that's continuous on a closed interval. So sure enough, it's closed. It goes from A to D. It doesn't go on forever, right? It's a closed interval. Okay. So this function, and it has to be continuous. This function, it's guaranteed to have absolute maximum and absolute minimum. So how do we do it? Normally, you don't have a function that looks this bad. Normally, you have a function that has one definition from A to B, from A to D, let's say, right? So what do? You find the critical points, right? By taking the derivative, set it equal to 0. So you find the critical points. Then you collect all the critical points here, all those x's. You also collect the endpoints, A and D. And you say, okay, what's the y coordinate? And you check all the y coordinates. The largest is the maximum, the smallest is the minimum. The only difference here is that you have to do this for this piece, find the derivative, set it equal to 0. For this piece, find the derivative, set it equal to 0, find critical points. For this piece, find the derivative, set it equal to 0. Now, the critical points you find better be in here. Those critical points you find for this piece better be in there. If they're not, you toss them aside. The critical points you find by taking the first derivative, they better be between 1 and b, and not bb, right? If they're not there, then you ignore them. So you take all those critical points, which are going to be more now, and you take all the endpoints, the a, the b, the c, and the d. You take all of them. There's a lot more now to put on your table. That's the only difference, right? So the function was, what is that? 1 over pi sine pi x, and then 2x. And the interval goes from 0, including 0, 1, not including 1. So if here you find a critical point that's equal to 1, 1 is not included. You throw it out. You don't consider it. Okay, here you go from 1 to 2, excluding 2, and here you go from 2 to 4, including both 4 and 2. Okay, so I'm going to take the first piece and take the derivative. So I want to find critical points. The first piece, take a derivative, set it equal to 0, and find critical points. The second piece, take the derivative, set it equal to 0. Third piece, take the derivative, set it equal to 0. That's how I'm going to find the critical points. But the critical points that I find, again, I have to check them that they're in the right interval, in the corresponding interval. If they're not, I throw them out. So let's do the easier one here. Take the derivative. I get it 2. Okay, that's never 0. So we're good. No critical points. This is not 0. So, okay, awesome, because there's nothing to worry about here. Okay, I take the derivative, negative 2x plus 6, set it equal to 0. There is an x that does that. Okay, so x is equal to what here? Mm, 3. So x equal to 3. I check. This guy came from here. Is 3 in here? Yes, it is. So I'm going to keep that. I'm going to put it in my table. This gave me nothing. Fantastic. I don't have to worry about it. So now I'm very careful with that. 1 over pi doesn't bother me. It's just a constant. It's left alone. It's a constant factor. Don't use the product rule here. That would be overkill. The derivative of sine of stuff is cosine of stuff times the derivative of the stuff. The derivative of the stuff is the derivative of pi x. The derivative of pi x is pi, right? So this thing here is pi. So I have 1 over pi cosine of pi x, and outside I have another pi. So the pi's cancel. And I will set this equal to 0, and I'm going to find when is cosine of pi x equal to 0. Well, cosine of whatever is equal to 0 where cosine is the x-coordinate on the unit circle. Yeah, so right, so it's equal to 0 here and here. So it's equal to 0 when the angle is pi over 2, the angle is negative pi over 2, the angle is pi and whatever, the angle is 3 pi over 2, those type of things. So theta, when theta is pi over 2, when theta is 1 pi over 2, 2 pi over 2, 3 pi over 2, right? And more, and negative pi over 2, and so on. There are all these things. But my theta in this case is that. So I want this thing in the interval I'm interested in, because I have restrictions. My interval doesn't say you're allowed all numbers. I'm not allowed to consider all numbers, and that's a good thing because I can't have infinitely many critical points. That would be crazy. So these are the only numbers I'm allowed to consider for x. For x, not for theta. Theta is pi x, right? Numbers between 0, including 0, all the way to 1, not including 1. So noting that theta is equal to pi x, I wonder, is there an x in the interval from 0 to 1 that gives me cosine theta equal to 0? So is there an x that makes theta equal to pi over 2 or makes theta definitely not negative, right? What x would work where the theta is exactly one of those angles? Right, a half. So x is equal to a half would work, and sure enough, a half is in here. So that's a critical point. So I have two critical points that I need to consider. So my table will have the half, we have the 3, and then it will have all the endpoints. So we'll have the 0, we'll have the 1, we'll have the 2, and we'll have the 4. Okay, so these are my x's, and then my f of x's. So you'll say, okay, what do I plug in? I have 3 pieces. Well, you have the first piece, that's from 0 to 1. So if there is an x that's from 0 to 1, like this guy, you're going to have to use the first piece, right? Because the half belongs in this piece, right? The second piece goes from 1 to 2, excluding 2. So if you have a number from 1 to 2, like this number, you have to use the second piece, right? Why is a half? Okay, I'll come back to it. And then you have the third piece, whatever it was, and you're allowed to use this piece if your x's are numbers between 2 and 4. So this x and that x and that x, all of those, you're going to go to the third piece to plug in. So f3 of 3, f3 of 2, and f3 of 4. You plug in on the third piece. The 0, you have to plug in on the first piece. The half, you have to plug in on the first piece. Right? So you plug in the right pieces. And then you compare. Now, why we said the half? So we said, again, we had cosine of pi over x. We want it to be equal to 0. And we said, what x does that? This is your theta. Cosine of theta is equal to 0 when theta is equal to pi over 2, 3 pi over 2, negative pi over 2, and it goes on. Bigger angles, both negative and positive, right? So this is your theta, this thing here. So the question, when is pi over x equal to pi over 2? Let's see, the pi's go away when x is equal to a half. And you wonder, is a half a good number that I should consider? Well, this derivative came from the first piece of the function. The first piece allows x's from 0 to 1. And the half is a number between 0 and 1. So you will keep that. That's a good critical point, right? If you continue here, again, this is your theta. The theta can be pi over 2, 3 pi over 2, negative pi over 2. All those thetas make cosine of theta equal 0. So you say, my theta, can it be 3 pi over 2? If it's 3 pi over 2, then x is 3 halves. But the x is only allowed to be between 0 and 1, excluding 1. And 3 halves is not there. So I'm excluding that. Can't use it. So you go on and you say, how about the negative stuff? My theta, again, is this number. So my theta, can it be negative pi over 2? Again, get rid of the pi's. That means x is negative. Well, that's not possible because x has to be here. So you stop. Okay? Because if you continue here, you'll get bigger and bigger x's. And already that was too big. And if you continue here, you get negative x's. And none of the negatives are good. So there's only one good x in that interval. Right. Yeah, that's very good, Rachel. Okay, so questions? Seven. Okay, that's a box. Okay, so you have a box that has a square bottom. Right? So you have whatever. So so the volume is constant. So the volume is fixed. You can't change it. So the volume has to be 12 something. The units only come, in play in your answer. You see 12 and you just write 12, forget the units. But when you go to write the answer, then you go back and look at the problem what the units are, right? So you don't write, meters instead of feet. And if you write units for volume, have to have a third power, units for, area, have a square power and so on. All right, so you have 12, the volume is fixed. So I guess you decorate it or something. Construction costs, okay, so the top costs a certain amount of money per square foot, right? So the top here, you don't know how many square feet is the top, right? What's the area of the top? But the top for each little square foot, it costs $1. So this is $1 per square foot. So if the top is, let's say, 20 square feet, it will cost you $20. If it's a half square foot, then it cost you a half times 1. So it's a half, $1, and so on. Right? So it doesn't say the top costs $1, right? It costs $1 per square foot. The sides cost $2 per square foot. So all the sides here, $2 per square foot. On the bottom is free or something. What's the bottom? Okay. Oh, the bottom is even more expensive. So the bottom is $5 per square foot. So the bottom is $5 per square foot, right? So they're going to ask you something about the cost, right? So minimize. Yeah. So nobody wants to spend too much money doing this. So they say, okay, what kind of box should I have that has the volume I want, 12, cubic feet, but I don't want to spend too much money for it. So, oh, okay. So you know that the base is square. So again, here's the thing. So if the base is square, so this is x and that's x, right? That means the top is a square also. That's x and that's x. Top is square. But you have no idea what the height is. It could be the same or maybe not. No clue. So let's call this y since we don't know, right? So the area of the top is what? X squared. The area of the bottom is also x squared, right? Because it's the same thing. Now the area of the sides, how many sides do we have? Yeah. So what's the area of each side? And there are 4 of them. X times y, right? The x times y. X times y, right? So x times y. So the total, so the cost function, it will be the cost for the top plus cost for the bottom plus cost for the sides. The area of the top is x squared. So x squared is the area. So x squared could be 13 square feet. X squared could be 12 square feet. I don't know what x squared is, but it's a number in square feet units. So if I knew what that number was, don't know what it is. Since I know the top cost $1, then if that number was, 12 square feet, then the top cost $12, right? Because the top costs however many square feet you have times 1. So the cost for the top is that times 1. The cost for the bottom is however many square feet you have times 5, right? And the cost for the sides is however many each side. It's how many square feet you have times, what was it? 2. But you have 4 of these guys. So these are all the sides. So I'm going to add all the costs together. So the cost of the top is x squared times 1. Cost of the bottom is 5 times x squared. And I have 4 sides. So 4 sides, each one costs that much. Right? So I have a function for the cost that unfortunately is not the type of function I want because he has too many variables. So it's that many x squares plus 8xy. I want a function of one variable. So I need to try to eliminate one of the variables, and that's why they're giving me volume. They say the volume is fixed. So if you have a box that has base x and x, the two, length and width at x, and the height is y, what's the volume in terms of x and y? Yeah, x times y. So the 12, which is volume, is x squared times y. So there is a way to eliminate y. You can write y in terms of x's. So y is 12 over x squared. So I'm going to use that to write my function in terms of only x. So now I have a function of one variable. Because y is 12 over x squared. And of course, sides are not negative length, right? They don't have negative length. So I can simplify here and no worry I end up with, negative number or anything weird. That's fine. So I can simplify. So I have, and please don't bother multiplying. There's absolutely no reason for that. So I'm asked to find the minimum of this. Okay, yes. So we know that the volume of a box is length times width. Okay, my handwriting is large. So times height as opposed to width times height. So the length is x, the width is x, the height is y. So this is x times y, but they told you the volume is always 12. Okay, so therefore y, x squared is equal to 12. Therefore y is equal to 12 over x squared. Okay. So the problem will give you something to go to get rid of one of the variables. See, the first sentence, the volume is 12. I'm like, okay, who cares? Because I'm finding cost that has to do with area. There's a reason they gave you the volume. So you can replace the y, right? So Right, so I want to minimize. So if you're given any function and they're saying find the minimum or the maximum, whatever, what do? You find a derivative, right? You find a derivative, you find a critical point. So here's a critical point or 2 or 3, however many. And you say, okay, it's the derivative. Is this positive? Is this negative? What is it? You know, the derivative. And if it's positive and then becomes negative, that goes up, that goes down. It's like, oh, look, I have a maximum there. So do you want the cost to be maximum? I found it, right? In this case, the cost, they're asking to find a minimum. So you will have a derivative and you'll have a critical point. If you have more than one, okay. But you should have at least one, and you should have a derivative for the cost function that looks like that, because you will find a minimum. So the derivative should be negative and then positive. You should be able to do that, right? So the function here was 6x squared plus 8 times 12, 1 over x. So I need to find a derivative. Now, before you find the derivative, please do not combine those. Okay? Don't torture yourself and the person who's going to have to grade that. Don't do that. So 12x, 8 times 12, nobody cares what it is, leave it alone, plus 8 times 12, don't bother with that. The derivative of 1 over x, the derivative, not the integral, don't write natural log. Plus, you know, if it's natural log, you're going to have a hard time solving for x. So you know that's incorrect. So 1 over x is the same as x to the negative 1. So the derivative of 1 over x is the same as the derivative of x to the negative 1. So what's the derivative of that? Of this thing? I just said not to put natural log. The derivative of natural log is 1 over x. It's not backwards. The derivative of natural log is 1 over x. It's not true that 1 over x, the derivative is natural log. No. There's no such formula. You know the formula that says x to any power, negative 1 or any other power. There is a formula for it that says bring the power down and write 1 less power. That includes it. There's no restriction on the n. Includes x to the 0. Well, okay, yeah, that's fine. Includes x to the negative 1, like in this case. That's not correct. What do? You bring the power down and you write the power with 1 less number, right? That's one rule. There's no restriction on the power, so there's only one rule there for power functions for the derivative. The integral has rules, but we're not taking an integral here. So then this is the derivative here is negative 1 over x squared. Okay, so now I want to set this equal to 0 and find the x. If you want to, you can combine this into one fraction. No need to do that. So I'm going to take this weird stuff. Again, don't bother with 8 times 12. Leave it. Oh, that's a minus now, because there's a minus there. Minus 1 over x squared equal to 0. So I'm not going to bother combining into one fraction. There's no reason. I'm going to separate the terms, put them in different sides. So 12x is equal to 8 times 12 over x squared. And I'm going to combine, I'm going to cross multiply, right? So that means 12x to the third is equal to, now doing that, I lost something. I'm going to tell you in a minute. It doesn't matter in a word problem though. So what I'm doing here, I'm cross multiplying, right? So 8 times x squared, which is 12 times x to the third, is equal to 8 times 12. So the 12s can cancel, which is a good thing I never multiplied. So you have x to the third is equal to 8, therefore x is equal to 2. Okay, so if you're, 8 was some other number, huge, you don't have a calculator, because if you do, that's academic integrity violation, so you don't, right? So it's like a huge number. So you're like, I have no idea. Can't believe they expect me to know the cube root of that. No, we don't. So you write the weird number that you gave me, cube root. Don't know what it is, and don't bother with it. Right? So if you're not sure, just write it, cube root of 8. Nobody cares that you don't know what that is. So, but in any case, this is pretty straightforward. It's 2, and you can check 2 times 2 times 2. Yeah, that's 8. Okay. So now that you know what x is, it's not enough to say the correct width and length is 2 feet, right? Or whatever the question is. You need to actually prove to them that that's where you're going to have a minimum cost. So the x cannot be, x is a length, right? Cannot be less than 0. That will make no sense. And it can be 0. You can't have a volume of 12 if one of the sides is 0. Right? So that's not good. So you have this interesting number you found, and then it can get bigger and bigger and bigger, the length. So the derivative, I don't even have to plug in. It's unless there's a huge issue in the problem, there won't be. The derivative better be negative and then positive because somebody's asking me for a minimum. So the function has to go down and then up, and then I'll say, oh, look, this is a minimum. This is required as part of your solution. To prove to someone that when you say x equal 2 is the one that will give you a minimum cost, you know that that's a minimum, not a maximum, because you've done this little table on the side that shows that this is a minimum. Let me cancel out. Yeah, but you don't have, are you talking about the derivative? Yeah, so, but you're, when you're taking the derivative of this, is it 0 times 3x squared? No. Does the 2 cancel? No. It doesn't. Right? A constant stays, doesn't go anywhere when you take a derivative. Constant factor, right? So when you have 8 times 12 with a derivative of 1 over x, this is the same as a constant, 8 times 12, times x to the negative 1 derivative. The constant stays, right? You mean check what? That the 2 is correct or that it gives you a minimum? So Ragini, I'm not sure what you're asking me. You can put your mic on if you want to.
If you were to check, like we know that it's gonna decrease then increase, but if you didn't know, would you plug it to like
To the
number?
derivative,
Okay, thank you.
right? The derivative is going to be negative and then positive. So you plug in any number, not 0 and 2. Plug in any number between 0 and 2, like for example 1. Plug in, you expect a negative number on the derivative, right? And then plug in any number after 2, whichever, plug in 1,000, whatever. And that should be a positive number. Okay. Okay, so you go, I don't know what the question was. What was the question? What dimensions? Okay, so you have 2 of the dimensions now. You have x is equal to 2 and x is equal to 2, and you know you want y. Well, you can find y because you have a formula for y. So if x is equal to 2, y is equal to 12 over 2 squared. Again, I would leave it like that. If the numbers are weird, please don't simplify. There's absolutely no need. But if they're asking me for dimensions, there's one more thing I need to do. I need to go and read the problem and find out the units. So if the units were, let's see, feet, length, width, and height are not feet squared, are not feet cubed, they're just plain feet in this case. So I will say the dimensions are 2 feet by 2 feet by this number that I'm afraid to simplify, feet. And that's how I'm going to write the answer. Okay, unless somebody says, can you tell me what the base is? What are the dimensions of the base? And I'll say 2 feet by 2 feet, and the height is whatever that number was, 3. Okay. Okay, don't forget the units on this type of problems. Okay. So area under a curve. So if it's like this, you have a top graph, y equal, you know, f of x. So y is in terms of x. Y equal, y has x's on the other side. You take top minus bottom. Top minus, so you put always large minus small. The small is the bottom stuff, right? So if your graph is this way, you have the curve in terms of x, y in terms of x, and you put the top y minus the bottom y. If you have it the other way around, then you have a formula that looks like that. This has all y's inside it, and this is another x with all y's inside it. Again, you put large minus small. So the integral is going to be the large, well, the larger, in this case, compare x to x's. The larger x is the one on the right. So you're going to put x large minus x small. Notice this is a difference in x's, right? So if you have x large minus x small, then you're integrating with respect to y. So you always have a delta x, delta y type of a case happening, right? One's going to be a d, and the other one's going to be an actual difference, right? The same thing here. If you have an area that looks like that, since you have a function y equal to some stuff and y equal to some stuff, you just subtract the y's. So you have y large minus y small. So notice this is a change in y's, right? And since you have the y's there, this is going to be integral with respect to x. You'll definitely have an area problem. There is, I don't remember now. There's one in the notes that looks like this. I'm going to come up with another one, but I think that's a good problem. And I think I did this 2 ways. Look at that problem again and learn how to set it up. So you had whatever parabola and a line, and I said if you do it with a line segment vertical, no matter where I move the line segment, which clearly has width that goes left and right. So the integral is going to have dx. This is always the width of the line segment, the fatness of it, how fat it is, right? Then no matter where I move it, the top of the line segment is always the line. The bottom of the line segment is always the parabola. Then it's going to be the top, which is a y coordinate, minus the bottom, another y coordinate. Y large minus y bottom, right? Y small. By y large is this line, right? Y bottom is this parabola. So you're subtracting from the line the parabola. And then the limits are the x value. So you go and see what's this x, that's going to be the bottom limit. What's that x, that's going to be the top limit. But then we did it again. So please look at this problem. That's a good problem to prepare you for what's going to happen on the exam. Okay, 13b, is that a similar problem? Oh yeah, so 13b is slightly more than you will see because it has x plus 2 squared minus 3 as opposed to x squared minus 3. But anyway, so let's see. So first I would graph those separately and find the intersection points algebraically and then attempt to put them together, the two graphs, right? So you have x squared looks like this. X plus 3 quantity squared. So when you add or subtract directly to the x, the graph moves the other direction. So if you add to the x, instead of moving the graph the way x moves to the right, you're moving it to the left. So this moves 3 units left. So instead of being here, that's going to be here. And you can tell when you plug in x equal -3, sure enough, y is equal to 0. Okay, so I have this graph, but this is not what I want, right? And I don't even know what this is, and I don't care right now. So I want this graph, but the y, I don't want it to be that number. Y, I want it to be that number -3. So I don't want the old y. I want to take the old y and subtract 3. So what happens to the whole graph? What do I have to do to it? To move down by 3 units, right? So I'm going to move this thing down by 3 because y moves up and down. So if you subtract 3, you move the whole thing down. So instead of being here, the vertex being at -3, 0, it's going to move down. The vertex is going to be at -3, -3. And then, of course, I'm afraid to go here. I don't know where to cut on the right. Is it +2? Oh, dear. Okay, so let's do the actual problem. The actual problem was x plus 2 squared minus 3. Again, the vertex will be opposite of this and exactly this. And because this is positive, the graph is going to go upwards. So if this is -2 and this is -3, this is the vertex and it goes like that. And you should be worried where to cut the y-axis. I'm not going to cut it unless I know exactly where to cut it. The place where I cut the y-axis, whether it's at the origin, above the origin, below the origin, I'm not sure. I know one thing about that point. I know the x-coordinate where I'm going to cut the y-axis. The x-coordinate is what? So if you cut the y-axis anywhere, what's the x-coordinate there? I don't want you to look at the graph here, at the equation. Yeah, the x-coordinate has to be 0. You don't know where that is, but the x-coordinate, regardless, has to be 0. So no matter where you cut it, here or here or here, the x-coordinate is equal to 0. So I'm going to plug in x equal to 0 and figure out where I should cut the y-axis. So my graph looks, remotely okay, right? So x is equal to 0, the y is equal to 0 plus 2 squared minus 3. So sure enough, I'm cutting the y-axis on the positive side. So now I can attempt to graph this. So I know it's going to go like this, and I'm going to cut on the positive side at 1. And this is -2, -3. So I have the parabola. And now I need to draw the line. So the line, and I'm going to draw it separately, originally, and then I'm going to find the intersection point so I can graph it. The line looks like, what's the line? Don't even know. 2x plus 4. So the line is y is equal to 2x plus 4. This is positive, so the line goes up. This is the y-intercept. So the line goes, cuts the y-axis at 4, so here, right, at 4, and it goes up. Okay, and I can even find out where it cuts the x-axis. I don't really care. I don't care if it cuts the x-axis here or if it cuts the x-axis there. I really don't care. What I care is where it intersects the parabola. That's the only thing I worry about. Where to go to touch the parabola. Okay, so I need to find the intersection points. So I want to know where the y of the parabola is equal to the y of the line. So in order to do that, you need to expand this. You will have a similar problem on the exam, only this is going to be nicer looking. So this is x squared plus 4x plus 4. And you seriously here, you should go very slowly. If you have to expand anything, because you're forced to, you gotta go very slowly. Don't mess it up. Minus 3 is equal to 2x plus 4. So I can cancel the 4's. Bring everything together. So I have x squared plus 4 minus 2x's, so that's plus 2x. Minus 3 is equal to 0. I'm hoping this thing factors. So I want two numbers whose product is negative 3. So one's positive, one's negative. But when they add up, you end up with when you add them up, you end up with a positive 2. What was that? Final review doesn't have a number 15, right? Of course it does. I'm just looking at it. Yeah. So the two numbers are going to be what? Whose product is negative 3 and whose sum is plus 2. What are the two numbers whose product is negative 3 and whose sum is positive 2? Whole numbers. Well, if the product is right, it has to be negative 1, 3. It's either negative 1, 3 or 1, negative 3. Well, in order to have a positive sum, the bigger one has to be the bigger absolute value has to be the positive. Okay, so it's a plus 3 and a minus 1. Product, sure enough, is negative 3. That checks out. Sum, sure enough, is positive 2. That checks out. Okay, so you have x is equal to negative 3 and x is equal to 1. What were we doing? We're finding intersection points. That tells you the line intersects the parabola at that x and that x. You really don't care where the y and x axes are now. You can just take them out. You don't care. And you might want to, so you can avoid position things the wrong place. So I can just draw this thing, and I can draw the line, and I know the place where they intersect, x is 1, and the other place is negative 3. And now I can find the y-coordinates. I can go either to the line or the parabola to find the y-coordinate, right? The line was 2x plus 4. It's easier to go to the line. And the parabola was x plus 2 squared minus 3. It doesn't matter where you go. I'm going to go to the line. So if I go to the line and x is 1, this is going to be 6. If x is negative 3, that's going to be negative 6 plus 2. That's going to be negative 2. Is it? Really? Okay, that's unfortunate. Okay, no, that's fine. Right? I don't care now where the x's are. So I would really advise you to take out the axis, because otherwise I'm going to have to spend more time to try to figure out, okay, where's the intersection? Is the intersection here, or should it have been down here, or should I do it in here? You don't want to waste your time with that, because it really doesn't matter where the x and the y-axis are now. It just matters where those things intersect. Okay, so really I didn't care where that was either. There's no point. Okay, so now that you have this, you can set this up two different ways to find the area. So the area is this thing. You can find the area with an integral in terms of dx. Is that what they're asking you to do? Yeah, so they're saying set up the integral two different ways, right? So that's what you want to do. You want to set it up two different ways. So one way, it would be with respect to x. If you're doing with respect to x, you should be y top minus y bottom. That means you put a line segment that's vertical, and that's the width. So if I put a vertical line segment, sure enough, or no matter where I put it, the top of the line segment stays on the line, and the bottom of the line segment stays on the parabola, so I need one integral. Okay? So, and Since I'm integrating with respect to x because the width, I'm moving the line segment left and right. That tells me integrate with respect to x, right? So the limits are going to be the x limits, how far to the left and how far to the right. So the x goes from -3 to 1, right? So the line segment, the y top is the line, the y bottom is the parabola. So the y top is the line, where the line is 2x plus 4, minus the y bottom is on the parabola. So the y on the parabola is x plus 2 quantity squared minus 3. Don't forget the parenthesis. So again, y top minus y bottom, whole thing, dx, and the x's go from the left, -3, to the right, 1. That's the integral. Okay? And they're not asking you to evaluate. Another you'll be asked to evaluate in the exam. So the other case, if you were to evaluate with respect to y, if you're asked to do with respect to y, that means you need to put a line segment that goes the way y does when you move it. So you move it up and down. If you put a line segment that moves up and down, it's not a vertical line segment. Vertical line segments can be put all the way to the left and all the way to the right. So if your line segment has width that's dy, it's horizontal. And that horizontal line segment can go as far as up as you can and all the way on the bottom of the region. So your line segment is horizontal. So you attempt to put a line segment and you notice there is an issue. The moment you go past this point, the left part of the line segment jumps. This part jumps from the line to the parabola, right? So that tells me that you need one integral here and different integral there. So this region, the top region, let's do it in green, this region requires one integral, and the bottom region requires a different integral. Again, why? Because as you move the horizontal line segment up and down, so you integrate with respect to y, one side of it, doesn't matter which one, it jumps to a different curve. So the moment it jumps, you need a different integral. So I'm going to need an integral for the, oops, what's happening? An integral for the top part with respect to y, and I'm going to need an integral for the bottom part with respect to y, and I need to add those two integrals. Okay. The top integral, again, I'm integrating with respect to y, so I need the limits. The top integral, the limits for the y are going to go from this y to that y. So I go back to my picture. The y here is -2, and the y at the top is 6. So my limits are going to be from -2 to 6. And for the bottom, for this part, the y goes from this y to that y. This y is from the vertex. The vertex, again, was -2, -3. So the y here is -3 all the way to this y, where y is -2. I can see it in the intersection points. So the bottom integral, the blue one, is going to go from -3y to -2y. So all I'm missing is what I'm integrating. If you're integrating with respect to y, you need to subtract x's inside the integral. All right. So this here that you plug in is the length of the segment. The line segment was horizontal. Its length is an x-coordinate minus an x-coordinate. The same thing with the bottom line segment. The length is this x-coordinate, the large one on the right, minus this x-coordinate. So let's do the one on top. So what you need to do here to find the length of this line segment, you need to find the x-coordinate here. That's the large x, and subtract the x-coordinate here. That's the small x. The large x comes from the parabola. So I'm going to write the equation for the parabola. And I need to solve for x because I want to know what x is equal on the right of the line segment because I want to subtract the x coordinates to find the length. So I need to solve for x slowly. So I'm going to move the 3 over here. So I have x plus 2 squared is equal to y plus 3. When you get rid of a square power, you really have to put a plus or minus on the other side. And now I'm going to solve. So I'm still looking for x. So it's minus 2 plus or minus root of y plus 3. When you have a parabola like you do here, why you have two different x's? Because one part, the part to the right of the vertex, x is equal to negative 2 plus root, and the part to the left of the vertex, x is equal to minus 2 minus the root. Okay, so the different pieces of the parabola have different x equations. Okay, so back here, this line segment, to find the length, I want to take the x here, which is on the right of the parabola. So that would be the x that's larger. The x is larger when I use the positive sign. I'm going to take that x and subtract the x on the line. So what is the x on the line? Well, the line was y equal to x plus 4. So again, solve for x. So 2x is equal to y minus 4. So x is equal to 1/2 y minus 4. So that's the small x, the x on the line. So the green area, again, you integrate with respect to y because you're going up and down with your line segment, goes from y equal negative 2 to y equal 6. And you subtract the large x, you take from the large x the small x. Okay, so in this case, that's going to be equal to, the large x comes from the parabola. What was it? Y plus 3. Minus the small x comes from the line, which is 1/2 y minus 4 dy. And to that, I need to add the other integral. So I need to add the blue area. The blue area, the y goes from negative 3 on the vertex to negative 2. And again, I have to subtract x large minus x small. The x large is again the right side of the parabola. X small is the other part of the parabola. So this is the same as from negative 3 to negative 2, the large part of the parabola, where the x's are large, minus the small part of the small x's on the parabola, dy. So this is the sum, right? So if you integrate with respect to y, you need to have two integrals and add them up. You will have a problem like that. You need to get comfortable with this. I'm going to come up with a couple more examples of this, and I'm going to add them up, and I'm going to post them by tomorrow morning. You should practice that. Setting it up, that is. About the exam, would it be around the same time? So no. Okay, one question at a time. I'm losing thing here. No. So is it Rain? I'm not sure how to pronounce your name, but anyway, so if I understand what you're asking, can you pick which way? Clearly, you'll pick the one that doesn't have 20 integrals, but you won't have a choice. You'll be asked to do it both ways. You'll not evaluate the integral, right? You'll be asked to set it up both ways, like this problem says. here's something, draw it, and also set it up with respect to x, and also set it up with respect to y. In one case, you're going to have one integral. The other case, you're going to have a sum of two. So you need to be comfortable with both because you'll be asked to do both. About what was the other question? Yeah, so the exam, how long is it? Hold on. Questions. It's long. But slightly obnoxiously long. I mean, I was hoping it wasn't that long, but it is. Yeah, I don't know if I should say. I don't want anybody to panic. It's 15 questions, a lot of questions. 15 questions, but a lot of them are short. Okay, let me take that back. That's not true. So a lot of them are short, but yes, but it will be very similar to the type of stuff you see in the review. See, problem one, okay, a gazillion parts, right? It will be kind of the same thing. So you can have problem one, you can either know it or don't, and it's going to be pretty quick, like problem one is in this review. Problem one has all these 10,000 questions, and they're all quick, and they're going to be similar, and you either know it or you don't, and it's full credit or 0 credit per part. So this should go quickly. Some of those that have many parts, right? You definitely will have enough time on the exam and enough time to go through your work and check it. So yeah, maybe I shouldn't have said that. I don't want anybody to panic. Yeah, of course, you don't have 80 minutes. Is it Rayhan? Yeah, you have 3 hours. 3 hours, a long time. Yeah. It's definitely longer than the midterms. Yes. But it's not double the midterms. Right? Yeah. It's long. You don't want to leave anything blank either on the exam. Please don't do that. That would be sad. What was the other question? Can you do number 2? Yes. On the one that I wrote it, like handwritten. Is that the one you're talking about? Okay. What was number 2? Yeah, so like, for example, that one is a short question. Either you don't know it or you don't. If you don't, you move on. So if you don't move on. You actually guess. Because nobody can give you negative points, right? You always guess if you don't know. Do the best you can. So you have the formula that says the derivative of x, e to the x is e to the x. And also you have the formula that says the derivative of this is itself, just like this is, times natural log of a. Need to know that. Also, you need to know notation. Notation says, well, in this case, you can write this way, or you can write it the derivative with respect to x of e to the x. It's the same thing. So if I ask you, so say f of x is equal to e to the x, and I say find the derivative of f of x evaluated at x equal 2. What does that mean? That means find the derivative at 2. So I can ask it this way. That would be too easy. Or I can just go ahead and write something weird like that. These are the same thing. They're telling you the same thing. Say find the derivative, and when you're done, replace all the x's by 2. Okay, so if the function was, let's say, 4 to the x, the derivative is, here's the formula, 4 to the x times natural log of 4, which nobody knows, and that's a good thing. Leave it alone. So if somebody says find the derivative at 2, if they ask it this way, you found the derivative, so now you plug in 2 for x. There's no x here, so don't plug in 2 there. Okay, and that would be that. Or they can ask the same question this way. this is the same question. That says first find the derivative and then plug in 2. So I'm going to find the derivative is 4x times natural log of x. And then I'm going to plug into, oops, natural log of 4, I mean, plug into 4x. So 4 to the 2 natural log of 4. Okay? That's all it is. Was that number 2 that you said? Okay. So what do you mean precalculus? What's precalculus? Yes. Yes, I don't know what they, I mean, you will, yeah, there will be some weird stuff from before. Let's see. Yeah, look at the review. Look at the stuff I posted, handwritten stuff with the awesome handwriting. And also, hold on, because I can't use my new computer, don't know how. What's happening? Okay. Give me a second. What is happening? Okay, I can't get it right now because something happened to the trackpad. Okay, I might have to take a break and ask my husband to come and help me use my Mac because I have no idea. I don't use Mac, and unfortunately I bought one. Don't know how to use it. What's happening? Oh, back to reality. Okay, good. All right, so so look at the review that's called One Final Dash Review Dash FA24 on our site. Look at that one. That's the same one that's posted on the coordinator side. On the all section side, look at that one and look at the review that the extra problems I posted. I'll add some more. There should be plenty to give you an idea of the type of problems that will show up. No problem that will show up won't show up included there somewhere. So, okay, about the sign. So give me a second, Miriam. So Lang with many, many G's. I can't believe that's your name though. I can't believe you asked that question. So what did you say about sine 2x? Give me a second. Think about it. What was that? So much stuff here. It's insane. Ah, yes. So, so you should know the following. You should know sine, cosine of known angles, like 0, pi over 6, pi over 4, pi over 3, pi over 2, the negative ones. Again, the sine is the y coordinate and the cosine is the x coordinate. You should know those. You should also know somebody gives you one of them for a non-known angle. Let's say they give you sine theta is, I don't know, 7/8. You should be able to find cosine theta. It's not enough to give you that. They also have to tell you where the angle is. So if the angle is here in the first quadrant, then you know both cosine and sine are both positive. So how do you do that? And vice versa. If they give you cosine is 7/8, how do you find sine? Again, if they tell you in the first quadrant, then you know they're both positive. If they tell you they're in the, second quadrant, then this is positive and that's negative, right? So how do you figure out what the other one is? You use the formula. The sine square theta plus cosine square theta is equal to 1. If you know one of them, you can figure out the other. But notice if I solve for cosine, the answer won't be 1 minus sine squared quantity squared. The answer will be plus or minus. So I really need to know, is it plus or is it minus? Somebody has to tell me what quadrant I'm in. So then if I know I'm in the first quadrant, I know cosine is positive. If I know I'm in this quadrant, cosine is also positive. But if I'm in this quadrant or this quadrant, cosines are negative. Right? So you should be able to do that. But, so you should know this formula. You should also know this formula. This is 2 sine theta cosine theta. So if somebody says, I give you a sine, can you find cosine? Yes, I can, as long as you tell me what quadrant I'm in. So let's say now I found cosine and I also have sine. Can I find sine of 2 theta? Yes, I can. If I have sine and cosine, I can find sine of 2 theta. It's this formula. So yes, you need to know this formula. Okay. Oh, so many people answering so correctly. Good. So, right, so problem 11, definitely about graphing. Okay, so let me mention quickly about problem 11. So, what was problem 11 again? That's not what you mean, problem 11. Which problem 11 on which? I can't answer if you ask too many questions. I lose sight. I lose, I would lose my mind if you asked many different questions. I don't know what to concentrate on. So let's not do that. So one final review. So problem 11. Oh, 1F. Okay, so let's do 1F and then I'll do 11. Okay, 1F says, that's not what you mean. Let's stop the questions for a second. I don't know where to go. Okay, so okay, so Srijan, you say 1F in which review? That doesn't help me. Review 1. Okay, so hold on. Is that you mean one final? 1F doesn't have a graph. Are you talking about 1E? Okay, 1E. Okay, that's better. So if you have a thing that looks like that, this is something here, whatever it is. So there's some numbers here. Let's call them C, D. They could be A, one of them. Then this is what Y is equal to. And you notice the Y is definitely not negative because there's no negative here. Y is not negative. So keeping that in mind, Y is not negative. So if you were to graph this, you're on top of the x-axis. Maybe you're touching the x-axis, but you don't go below because the y is not negative. Now I'm going to simplify by getting rid of the root. So y squared is equal to a squared minus x squared. So x squared plus y squared is equal to a squared. Y is not negative, so I don't have the whole circle. I only have the top part of the circle. And do I have the whole part of the top? Well, the limits will tell me. The limits will tell me, do I go from negative A to A? Then I have the whole top. If the limits say only go from negative A to 0, then I'll only have this part, a quarter of the circle, right? So if the limits were, again, I have the top part unless somebody changes the limits on me, that restricts me. So let's see, if I go from A to, not A, negative A to 0, then I only have from negative A to 0, I only have this part. So this integral then measures the area of 1/4 of a circle. Doesn't matter which quarter, it's still a quarter of a circle. I know the area of a circle, I use geometry to write the area of a circle and divide by 4. That gives me the red area. If the limits went from negative A to A, still the y is positive. That tells me that this measures the area on top, area of this thing, which again, it's half the area of a circle. This problem gives you from negative 3 to 0. What's 3? 3 is the radius. So this circle goes from negative 3 to 3. The y, here's your y, is definitely not negative. So you're on top of the circle, but the x's say to you, don't take the whole top piece, go only from x negative 3 to 0. So x goes from negative 3 to 0, so you only take this much. That's what this measures, the area of the red piece. So it measures a quarter of a circle with radius 3. So this is the area of 1/4 of a circle. So that would be 1/4 the area of a circle, which is pi r squared. So it's 1/4 pi r is 3 squared, so that's the answer. Don't simplify it. Now that would be crazy, Zainab. I mean, yeah, no, don't expect that. Yeah. Yeah, don't, no. I think I had given you something like that somewhere, but yeah, no. It's a final exam. So yeah, that was one neat. What was another question? I don't remember now. Can we do number 1 on the 0? Who says these things? Did somebody 30% to 70%? I don't know who came up with that. I don't know. What is chapter 5? Please. I'm pretty sure that's incorrect, but I haven't checked. Let's see. This chapter is this. Nobody knows. Definitely not chapter 5. That's chapter 5. So that's 16, 26, 36. Nope. Not even close. It's not, no, not even. No. How many points is this exam? I assume it's 200 points. So it seems to me like about, oh, there's a piece here. No, that's not it. Chapter 5. Maybe 40 points. No, okay, there's a little bit more here. What's that? No, that's geometry. So maybe like a quarter maybe. Yeah. So I don't know, but this it's reasonable. So somebody asked the question. What was the question? Do number 1 on 0 final practice. What's number 1? Yeah, let's do number 1. Yeah. So number 1 says tangent theta is equal to -3/2, and theta is an angle between pi over 2, 90 degrees, and pi. So let's pretend that's a circle. That's ugly. Okay. So if the angle is between pi over 2 and pi, oh, these are strict equal, okay, and pi, then you're over here. Over here, the x coordinate and the y coordinate are negative and positive, right? All the points here on the circle, the x coordinate is negative and the y coordinate is positive. Okay, so because x is the cosine and y is the sine, that tells you the cosine is going to be positive and the sine, the cosine is negative and the sine is positive. Cosine is negative, sine is positive. Okay, so now that you know that, you ignore it. You go ahead and use whatever formula you need to use to find cosine and sine, and then you stick the correct sign in front of it, plus or minus, right? Cosine should be negative, sine should be positive. Okay, so tangent. So how can I find sine and cosine from if I know only tangent? Well, you have a formula that's slightly painful. This is not the formula you necessarily need to remember. So that would be a more straightforward problem. Somebody just gave you the sine was a value, and they asked for the cosine, right? But since that was last year's review. But anyway, so there is a formula that says tangent square theta plus 1 is secant square theta. So you're like, okay, why do I care? Because nobody's asking me for secant. It's a good question. But if you know secant, cosine is not far away. Cosine is the reciprocal of whatever secant is. So if you know secant, cosine is just flip that. Now you have cosine. So if I know tangent is -3/2. So -3/2 squared plus 1 is secant squared. So 9/4 plus 1 is secant squared. I know the cosine is negative, so secant is negative as well. Right? Whatever cosine is, secant has the same sign, positive or negative. So secant is negative square root of whatever this thing is. So what is this thing? Oh dear, 9 plus 4. Again, I wouldn't simplify, but let's do. So secant is negative square root of 13/4. Can you simplify the square root of 4? Sure. Do you need to? No. So if that's what's secant, the cosine, which I'm interested in, it's the reciprocal of that. The cosine is still negative. Square root of 4 over square root of 13. Yes, you can simplify. Sure. No problem. But don't in the exam. Really don't. So now that you have cosine, you can find sine, because sine squared theta plus cosine squared theta is equal to 1. Again, you're in the second quadrant. The sine is a positive number. Okay. So you know the cosine, so you know the square. The square of this is 4/13. Again, we are here. The sine which is the y coordinate, is positive, right? So the sign is going to be positive square root 1 minus 4 over 13, not negative, whatever that number is. So the sine theta then, so I'm going to leave it like that actually. I won't simplify it because it's correct. If you simplify, you may do a mistake, so leave it alone. So the cosine then we said was negative root 4 over 13. The sine was positive 1 minus 4 over 13. Perfect. Now we have sine and cosine. We can find the rest. Specifically, you should know how to find sine of 2 theta. Sine of 2 theta is twice the sine times the cosine. So what do you have to do? Just use the formula and plug things in and don't simplify. The sine is this root. The cosine is a negative some other root. That's the answer. Again, don't simplify. If you want to find what cosine of 2 theta is, you need to know that formula. Or again, that you don't need to know for the exam. You need to know this, but you don't need to know that. You don't need to know anyway, even if somebody asked you that in the exam, because if you know this formula, you can find cosine of 2 theta. Because a cosine squared plus sine squared of the same angle is equal to 1. If I know this, I can figure out cosine of 2 theta using the same formula. The sum of the squares of cosine and sine is equal to 1. Okay, so this question would have been more appropriate. Again, if somebody gives you a cosine, it's known, and ask for the sine or the sine of 2 theta, or somebody gives you a sine, so it gives you a known number, right? A constant, and says, what's the cosine? And what's the sine of 2 theta? Or now that you know sine and cosine, what's the answer, right? But in order to do any of those problems, they also have to tell you what quadrant you're in. So you can figure out if the sine or cosine they're asking for should be positive or negative. Right, so this problem shows up also in the other review. So that's an important one to practice. The related rates. So I'll do that problem that you mentioned, but give me a second. So I think there's a picture for that because nobody wants. Yeah, there's a picture. Is that the one? Yeah, right. So there's a picture. Yeah, for that. Cylinder? No, it's a final. So number 16 on the same exam review on this weird 0 one. No, don't worry about arc sign. No. So you need to know in order to find that. Yeah, you need to know the derivative. No, nobody's going to give you a derivative of arc sign, although it's a nice one to know. So yeah, don't worry about that one on the 0 review. Yeah, I think then the other one doesn't have a number 16. Does it? No. Concentrate on the 1 review and the problems I'm giving you, which is similar to some of the 1 review. I mean, I'm going to add some more problems. Any other questions? So once I send that, we're going to have another review on Sunday. When's the exam? 12. Yeah, we'll have another review on Sunday. Number 8. Okay, number 8. Right. So that's a good one. Number 8. So number 8, there's also one that I added that's similar to it. Where is it? Did I? Maybe I didn't. Yeah, I did. Okay. So also do number 12 in the handwritten one. Do both. So number 8, these are similar problems. Only the one that I posted is slightly less painful. But you should do both. So, first of all, you're talking about a continuous function. So if you have a function that has one definition and a different definition, maybe some more. In this case, there are 3 pieces, but whatever. I'll do that in a second. And you have one interval here, let's say goes from A to B. So this is why does it do that? Okay, let's say it goes from negative infinity to something. And this goes, let's say, from 0 to something else. I don't know. Let's do 3 pieces. To 4, and let's say this goes from 4 to somewhere in one place. The 4 is going to be included, in the other place is not going to be included. It really doesn't matter where it's included. It doesn't. It doesn't change the way you're going to do the problem. Well, it changes it a little bit. Okay, I lied. So it goes to that. So they're saying to you the function is continuous. That means what? That means this piece is continuous, and when it finishes, the other piece starts where this ended. Okay, so the other piece, this piece, it starts where that ended. And the next piece, this piece, it starts where this ended. If it's continuous, it can't have jumps. So if it's continuous, then the limit of F1 of the first piece, F1 is the y coordinate. As x goes to 0, here's 0. So this tells you what is the y coordinate approaching. The y coordinate is approaching this number, whatever that number is, the y coordinate there. That must be equal to the value of the function at 0. 0 only belongs in the second piece, so it's going to be the value of the function at 0. Right? And it should also be equal. So this piece has to be there. The value of the function at 0 has to be there, and also should be equal to the limit of the other side, right? As x goes to 0 from the left is equal to the limit of the second piece as x goes to 0 from the right. So those have to be equal because the 2 pieces have to touch, right? So when they're talking about continuity, you're gonna evaluate. You're gonna be writing a lot of limits. So in this case, you have the following function. So f of x has 3 pieces. So x is less than 0. So this goes from negative infinity to 0, right? And then the second piece is ax plus 2b. And this goes from 0 to 5. And the next piece goes from 5 all the way to infinity. And that's 8. So for the function to be continuous, it says here after 5, the y coordinate is always 8. So the y coordinate is always 8. There it is, after 5. For the function to be continuous, this piece here, which is clearly a line, must connect here, right? So the limit of this function as x goes to 5 must be equal to the limit from this side. Those things have to be touching. Those limits have to be equal. So for the green piece here, again, the green piece, this piece, to connect to the other piece on the right, the y equal 8, the limits have to be equal. So I can write the limit of f as x goes to 5 from the left must be equal to the limit of f as x goes to 5 from the right, which has to be equal to f of 5. That limit, that point has to be there because the limits can be equal and you still can have a hole there. Still, the two sides are approaching the same thing, but there's a hole, so it's not continuous. So the limit from the left has to be equal to the limit from the right, has to be equal to the value of the function at 5. That's at 5. You should do the same thing at 0, at the other place where things might mess up, right? Might not give you continuous function. So just this piece alone allows me to write something. If I'm going from, oh, that's correct. If I'm going from the left side, if x is less than 5, then I'm here. So my f is this function. So the limit as x goes to 5 from the left, the f I need to plug in is ax plus 2b. If I'm going to 5 from numbers above 5, x goes to 5 from the right, then x is in this interval. So the f is the 8. So this is equal to the limit of 8 as x goes to 5. That's just 8. And this limit I just plug in, x equals 5. So I get 5a plus 2b is equal to 8. Okay, that's beginning, that's good, but I need 2 equations to solve for 2 unknowns, and I only have 1. So I must be able to find some other equation to solve for a and b. Okay, so I'm going to leave this alone, and I'm going to go back to the other piece. The other piece says this graph, whatever it is, oh, there it is, has to connect with a green graph because the function is continuous. And where do those pieces jump? They jump at 0. See, at 0. The red piece ends at 0 and the green piece starts at 0. So the limit of f as x goes to 0 from the left must be equal to the limit of f as x goes to 0 from the right. Those two pieces have to arrive at the same y coordinate, and that y coordinate has to be there. So again, the function is continuous. That means the limit at the other place where you have a little jump, it looks like, as x goes to 0 from the left, must be equal to the limit as x goes to 0 from the right, and that has to be equal to f of 0. Please write limits. You can't just go ahead and plug in. You can't just say f of 0 is equal to f of 0, and I'm going to plug in 0 at different places. There's only one place you're allowed to plug in 0, here, because 0 only belongs there. It doesn't belong on the top piece, right? But you are allowed to plug in 0 if you're writing a limit, right? So please write the limit there. This type of question requires that you write limits. Okay? So if x goes to 0 from the left side, that means x is this type of number. X is negative. If x is negative, f is the red piece. So I'm plugging into the red piece. Okay? So in order to find this limit, I need to plug into the left piece. So limit f is sine x over absolute value of x. And of course, you can evaluate limits or derivatives or integrals if you have absolute values. So your job is to get rid of the absolute value first. So I'm going to do that in a second. And then if I go to x is positive, then I need to use the green piece because that's where x is slightly above 0. So I need to write this in place of f. So the limit as x goes to 0 from the right of the f part where the x is allowed to be more than 0. So what was it? Ax plus 2b. So I'm going to plug in 0 on the right limit. So I'm plugging 0 in place of x. I get 0 plus 2b, which is 2b. That's awesome. And now I need to evaluate this limit. I can't unless I get rid of the absolute value. So since x goes to 0 from the left, how do I simplify the absolute value by itself? What do I do in place of it? Negative x, negative x. So this guy needs to be replaced on your paper by negative x. So limit x goes to 0 from the left, sine of x over x. You're like, oh, I remember this limit. What was this limit? What was it? What was it? Yeah, that limit by itself is 1, but there is a negative, so it's -1. So -1 is equal to 2b. That's awesome news because that tells me what b is. And if I know what b is, I can go in, plug it in, and solve for a. And when I say solve, I don't mean do anything crazy. So if this is an exam, I will say 5a is equal to 8 minus, not the chance, I'm not simplifying. A is equal to these things, which I'm not simplifying clearly, divide by 5. Is this correct? Yes, it's correct. If somebody doesn't ask you to simplify, you're not going to simplify because there were loads of you who simplified incorrectly. Okay, that was sad. Okay, so don't do that. So anyway, so you found A and B, right? So this type of question can show up again. There's a similar question that I wrote. Do that one as well. But that's the idea. You take a limit, 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 and then you have enough equations to solve for A and B. Anything else? Number 14, what's 14? 0. Let's see. Give me a second. So, no, no. What is this? Is okay. No, actually, that's no. So again, concentrate on the one review and the problems that I wrote down. Concentrate on those. I think I should take the 0 out so it doesn't overwhelm people. I think I'm going to erase the 0 one. Right. Right. So Miriam is right. It's you can either do 1 minus cosine x over x as x goes to 0. Since this is 0, so is the limit of cosine x minus 1 over x. Whatever this limit is, this is the opposite number. Since 0 and minus 0 are the same thing, so they're both 0. Yeah. Anything else? Handwritten review. Okay, so which one was that? Hold on. Ah, yes, that's a good one. Okay. Let's write it in purple. So we have f of x, nobody cares what it is, but we know that the limit as h goes to 0 of, oh, by the way, before I write this, the derivative of that, we know how to find it, but there's a definition. Definition of the derivative, one of them, they're all similar, says this. Okay, that's the definition. So if somebody asks you to find the derivative at 8, that is the limit, say it goes to 0, of f of 8 plus h minus f of 8 over h, right? And somebody told you what this is. They said this is 11. So 11 is the derivative of f at 8, because that's the definition of the derivative of f at 8. It's this limit. So the derivative is 11. Okay. Now, if I know what the derivative of a function is, let's say I have a function in mind, I'm not going to tell you what it is, I did the derivative, and ends up being, let's see, something. Like, it could be anything. So let's say the derivative at x, not a particular x, just x. The derivative is, I don't know, sine x plus 1 over 4 over x plus 2, whatever. Then if I know what the derivative is equal to, what's the derivative? Not at x, but at x squared. How do I find that? What's the difference? If I know one derivative at x, what's the derivative at x squared? This is the same question as this one. If somebody tells you the derivative of a function, here's the formula for it. And somebody says, okay, you know what? I'm going to change things slightly. I'm going to change all the x's to x squares. And you're like, cool, because I know the chain rule. I just learned it. So I'm going to use that same formula. My x's are going to be replaced in your formula you've given me by x squared, but I also am going to multiply by the derivative of x squared. So all you have to do is take the answer they gave you with the x's in the derivative, right? The derivative answer, and plug in x squares. So the answer would have been the same as that, only the x's are x squares. Or more importantly, you also have to multiply by the derivative of x squared. That's important. Times the derivative, because that's what the chain rule says. Times all that stuff, the derivative of x squared. So why do we bother with this? Because they're telling you here the derivative at 8 is equal to 11. And that derivative we know is equal to the limit. But they're also telling you, okay, let's pretend, they're saying, where is it? That I have a different function, and this is the function f of x to the third. Okay. And the derivative of h is the derivative of f evaluated at x to the third times, the chain rule says, the derivative of x to the third. That's the chain rule. Right? This is exactly what I did here. I took this derivative, and since my x's were replaced by x squares, I'm going to replace all the x's by x squares. I did it, but I also used the chain rule because you took a formula and you replaced my x's by something else. So I need to use the chain rule, right? That's exactly what this thing is saying to you here. Okay, so I know what the derivative of x to the third is. That's 3x squared. So the derivative of h at any x, and they're going to ask for a specific x, they're going to ask for 2, is equal to the derivative of f at that same x to the third times 3x squared. Okay. So if somebody wants the derivative of h at 2, that's the same as the derivative of f at 2 to the third times 3 times 2 squared, right? The x's are replaced by 2. So this is the same as the derivative of f at 8. Oh, that's good, because I know that one. That's 11. times 3 times 2 squared. Do we care what that is? No. Do you want to multiply? No, because you might end up with 10. It's an exam. You'll stress out. You'll do weird things. That's the answer. I'm not going to multiply. Okay. So the key thing here is to notice that when somebody gives you a limit that looks like that, let's say f 4 plus h, let's say f of 4 over h, and let's say this is 13, they just gave you the derivative at 4. Okay, and if somebody says find the derivative of this thing, you need to know it's the same as the derivative of the function with the x is replaced by x to the third times 3x squared. So if you know this because somebody gave it to you at a particular x, all you have to multiply is by the right amount. Okay. I think there was a problem like that. I'm not sure. Also in the review, check it. But that's a good problem. Okay. Questions? It's kind of cold. It's not good. Okay. All right. So look at the handwritten review. I'm going to add some problems. Look at other problems in the number 1 review. I'm going to erase the 0 because there's a lot, plus there were some mistakes in the solutions I found out. I didn't write them. Oh, but I didn't. Anyway, so I didn't write the other one either. The number 1. I wrote the handwritten one. So, so look at that. Look at those problems. Look at similar problems in the number 1 review, and then I'll have another review on. I'm going to add some more problems by tomorrow mid-morning, hopefully, or maybe a little bit later, and then I'm going to have another review on Sunday. Don't wait till Sunday. Do those problems. If you do those problems, nothing will be a surprise. Everything will be things that you've done before. You should be very comfortable going to the exam. Right? But you need to practice a lot because there's a lot of, it looks like, like when I opened it, God, it will be flabbergasted. So it seems like a lot of parts, but a lot of them are quick, right? Some of them are very wordy, which is unfortunate, but they should go pretty fast. No, the 0, I'm going to erase the 0. So you should focus on, no, you should focus on exam 0. What's exam 0? No, I don't even know. I don't check those things. So, so focus on the number 1 review, which is the same as the final review that's posted on the all section site. Focus on that, and the handwritten one. Nothing else. Those should be enough. Mary. Oh no. I'm a little bit sleep deprived. I don't know. Maybe if there's a need, just let me know. Like Saturday. Let me know on Saturday if you get very stuck. Maybe I can just write some stuff. If they're gonna be handwritten, I'm not gonna have time to type. So yeah. Okay. So what was the other question? Review 1 3D. Okay, 3D. Was that the question to like do it? 3D. Yes. So that's a little bit overboard, 3D, but it has a similar idea to something that will show up. So it's a similar idea. So if you have a function that has x's and more x's on top of the power, and somebody says find the derivative of y, don't do chain rule. You just can't. You can't take the derivative of x stuff to x stuff in the power. Can't. So what you need to do first, before you attempt to take a derivative, is break up this form. Take the power that has x's and take the base that has x's and separate them. Don't put them on top of each other the way they are. So your first job, say I can't do it, you need to split those things. Take the power away from the base. So the way to do that is to take a log on both sides. That allows you to take the power away from the base. So the natural log of y is equal to g natural log of f. So in other words, if and then take a derivative on both sides. So in this case, you have y is equal to some stuff with x's, and the power has more x's. You cannot take a derivative. Like no clue, can't do it. So what do you need to do? Break the form. So log of the left is equal to the log of the stuff on the right. So the whole power needs to come down. Where? Outside the log. So natural log of y is equal to tangent times stuff. So if you're going to take a derivative of these two, of this equation, both sides, the right side is a product. Tangent times stuff. So you're going to use the product rule. Here's one piece, here's another piece. So since I want to take a derivative eventually, and this is the time to do it, I'm going to have to take a derivative of this thing I'm looking at. So the derivative of the left side is equal to the derivative of the right side. The derivative of the left side is 1 over y times y prime. If you forget the y prime, you'll never find y prime. It's nowhere to be found. And somebody's asking you for y prime, right? Equal to the derivative of the right side, you need to use the product rule. Derivative of tangent, leave the log as is, plus tangent, take the derivative of the log. Okay, so you have 1 over y prime is equal to the derivative of tangent is secant squared times log plus tangent, and the derivative of that terrible stuff, the derivative of log of stuff is equal to 1 over the stuff times the derivative of the stuff. So that's what I'm going to use. The u here is these things. So the derivative of log of u is 1 over u times the derivative of the u, which is 2x. So what do I want? I want y prime. So all I have to do is to get rid of that 1 over y that's attached to it. So by taking y on the other side, multiplying by y. So y prime is all that stuff. I'm not going to rewrite them, it's too big. Times y. Your answer should not look this way. Your answer should just have x's. So how is that possible? You go back and you say, what was it again? The y? It's this thing. So in place of y, you write that thing again. So y prime is all that stuff we just found. Don't forget the parentheses around it. Times the y, which was, I already forgot, x squared plus 1 to the tangent. And that's the derivative. That's a standard problem. But usually, you get easier things like, I don't know, like cosine x to the x or x to the x squared. There's simpler things. Again, even that's not too hard to do. Get tangent, you might forget the derivative though. So number what? 5. Hold on. What's number 5? Oh yeah, so number 5, didn't we just do that? Oh, number 5, there's a mistake. I'm gonna fix it. As I said, is that this you're talking about, this thing? Is that the one? That's supposed to be a B? Let me write the B this way. That looks like a 3. A capital B. Is that the one you're talking about? Yeah, right? Okay. So this thing, it has this form. A, B, that's a B now. This integral is the limit as n goes to infinity, k equal from 1 to n of f of xk times delta x. So where this, again, this will be similar to an exam problem. You should know this. I mean, this is not something you've been tested on. So you'll be tested on this. You haven't been tested on area between curves in an exam. You'll be tested on this in the final. So the things you haven't been tested on, you'll be tested on the final. There will be problems like that. I mean, it's naturally. So delta x is, so what's delta x? So somebody has, again, a graph. And then the x-axis could be above the graph, below the graph, or in between the graph. Nobody cares. And you have an A and a B. And they're asking you to do this. So what's delta x? Somebody takes this interval from A to B and cuts it into many different pieces. Each piece has the same length. That's your delta x. So delta x is not as big as AB. So it's not B minus A, but it's B minus A divided by n. So the length of B minus A, from A to B, which is B minus A, divided by how many pieces you have. So that's delta x. This thing is B minus A over n. So the formula there looks like exactly like that. The formula you have some stuff times something that has an n here. That thing here, this thing that you see in the formula, is your delta x. So what is that thing in the formula? That's 9 over n. That's your delta x. So that means 9 delta x, oops, is equal to 9 over n, but delta x by definition is b minus a over n. Right? And the other side of the formula has an integral from 2, and I'll show you where the mistake is, to b of something. So the a must be 2. So 9 over n is equal to b, unknown, minus 2 over n. So you can find b. Whatever b is, it's right there. Right, you can find b. Okay, so now that we know b, what is f? This thing here is your f, but evaluated at different x's, specific values. So if you see, so what are those values? So if your function was, if your f was this function, sine x plus 4 over x squared plus 3, then inside this formula, you're going to see something that looks like sine, and again, your a starts at, let's say, 2. You will see 2 plus a bunch of delta x's plus 4 over x squared. So x is going to be 2 plus a bunch of delta x's, the x squared plus 3. You're going to see something that looks like that. So notice this quantity is going to show up again and again. That quantity is what has replaced x. So when you see that quantity again and again with delta x attached to it, and what is your delta x? Delta x is this thing that's outside the parenthesis. That's your delta x. So you see a bunch of those attached to your a, right? A plus a bunch of delta x's. That is what you need to take away and put x in place of, right? So if I see something like that, times my delta x, then I know my function is sine of x plus 4 over x squared plus 3. So in this particular case, the mistake was that this should look like 2, not 23. I like 23, so I stick it whatever I can. That was the wrong place to put it. So that shouldn't be 23, it's 3. So that's 3/2 times 9/n. This, where is it? Is your delta x. So here it is again. So this does look like your A plus a bunch of delta x's. So this is what you're going to take away and replace it by x. Right? So this whole thing is your x. So your function is x to the 3/2. Right? So again, your function should be x to the 3/2. Here's your delta x. So here's another example. So if you had and your a in the integral, your a is 2. This is 2. And here's the 2. And here's the delta x, because you know it. There it is on the other side. Here's your delta x, and you have k of them. So you have a plus k delta x. That's the quantity that you're going to take away and replace it by x. So this whole thing, a plus k delta x, and this whole thing, that's your x. So your function is x to the 3/2 plus square root of x plus 4. Okay? Okay. So let's see. All right, so what time is it? It's 9:42. I can take one more question, and then I'm going to stop and make a warm coffee. Number 11. Okay. Yes, that's a good question. Do that problem. Yes. So y equal to f of x. So you have a function, and you know the second derivative is equal to 24x squared. How can I find the first derivative if I know the second? How do I go up from the second derivative back to the first derivative? What do I have to do? Coffee. There's no bed, Nicole. There's just coffee and then more coffee and then up and have more coffee. And then gardening. Rocks. So, okay. So how do I go from a derivative to a less derivative? What do I have to do? Okay. What's another word for antiderivative? That starts with an I. I have to integrate. Right, I have to take an integral. So this is going to be the integral of 24x squared dx, which happens to be an indefinite integral. So you can't write the answer without the plus c. You do that, it's bad. Upsets the grader very much. So then the first derivative is equal to, let's see, what's the integral of 24x squared? What is it? 24 stays. What do I do with the power? Yeah, the third over 3. Again, if you really worry, don't simplify 24 over 3, although it does simplify nicely. Plus c. Okay, so since I don't worry too much that I'm going to do a mistake, nobody's grading me. That's what the derivative is. So now I'm going to go back to the problem. The problem says, what does it say? It says find the function. It doesn't even have a question. Where's the question? I forgot the question. Also, I'm going to fix that. So the question was, what is that? That is really the question. And also the question is, what is f prime equal to? F prime of x. equal to? That's the question. Okay. So you know that that's what the function should look like. The derivative function should look like this. But you don't know exactly what the c is. But they're telling you what f of 2 is equal to. They say f of 2 is the number 65, the derivative of f at 2. Right? The derivative at 2 is 65. So that would allow you to find c. So that says the derivative at 2 is 65. So how do I find the derivative at 2? I plug in 2 inside here. So 8 times 2 to the third plus c. Okay, so 65 is equal to 8 times 2 to the third plus c. So that tells me what c is. Therefore, c is 65 minus 8 times 8. So c is 1. So that tells me what the derivative function is. So that I know this function now. And now they're asking for the original function. Well, the original function is the integral of that. That's a 3. So the original function is 8x to the fourth over 4 plus x plus c. That's a different c. Maybe it's the same one. I don't know. Maybe it's the same one, but I don't know. Right? So the original function has this form. I need to find the c. So they're giving me a piece of information. I only need one piece of information because I only have one unknown. Right? They're telling me f of 2 is equal to 30. Okay, so what's f of 2? I plug in here, x equal 2, I should get 30. That would allow me to find c. So 30 is what you get when you plug in 2 inside this function. Okay, so c is 30 plus minus this, minus that. Minus 2 times 2 to the fourth, minus 2. All right, let's actually subtract here. So that's 2 to the fifth. That's unfortunate. Minus 2. So c is what? What's c? It's negative, right? It's negative 4. Okay, nobody asked me to find c. They asked me to find f of x. So f of x, then I go back. What was f of x? This thing with the correct c. F of x then is 2x to the fourth plus x minus 4. I can check if it's correct. Let me find what f of 2 is. It better be 30. It is, because that's the correct c. Okay. Now this is a chapter. Is that chapter 4? No, that's chapter 5, I think. No, I don't know. I don't remember anymore. Okay. Okay, so again, I'm gonna come up with some more problems. I should have them by tomorrow midday. No, I don't know, by morning. And then once I have them, I'll email you. I'll let you know. So tomorrow's what, Saturday? What day is the day? Oh no, it's Friday. Okay, so I will email you, and then sometime tomorrow I will also email you the time for the review on Sunday. Okay, but continue studying those problems. Those problems that you have now from the handwritten notes and the one pretty much have most of the problems. I'll just add a couple more. Okay. All right. So I'll see you guys on Sunday, hopefully during the review. Okay. Have a good night. Yeah. Thank you.
Professor,
Yes.
can you stay a little after? I just have a
Y-
prep question.
Yeah, sure.